Alright, so what we are now going to do is we are going to mark the 30 degrees, 60 degrees, 45 degrees too, 120, 135, and 150. And make those markings, please. And then turn your paper over, like upside down, and do the exact same markings to the bottom. So make sure this lines up with your x-axis right here. 30 degrees, 45, 60, 120, 135, and 150. And then very beautifully, very neatly, please fill out this unit circle. I'm going to do it the same way I've been doing it, quadrantals first. Don't forget 360. Then I'm doing my 30s. And then I'm doing my 45s. And then do your radians, please. Bless you. Again, please do not write anything extra on this. We are going to add more to it on Friday and on Monday. Okay, y'all rather take the quiz before we take a bunch of notes over something random? Okay, so I'm going to give y'all about 3-ish minutes if you want to write it again on your marker, whichever you are going to do. I'm going to give y'all time to finish this too. And then we will start quiz A. So we're going to add a fourth page. I think I just showed y'all my first periods book, so I didn't make this one yet. So go to page 3, what we started yesterday. And I didn't go over anything, I just had you write it down, right? Okay. Okay. Can I change that? So page 3 was unit circle vocab. So we talked about an angle. An angle is two rays that have a common vertex or that have a common endpoint. So, let me write that down real quick. Did I have endpoint or vertex for y'all? Vertex, okay. Either one, it's the same thing. The part down here, at least specifically for our unit circle, is going to be called the initial side. And the part up here will be called our terminal side. And when we have an angle in standard position, that is when you have your the initial side. It's on the x-axis on the positive side, meaning it starts at 0. And we're going to do some pictures in a second to show that, show some angles in standard position. The last thing that you should have written down yesterday was a coterminal angle. And coterminal angles are angles that are in standard position with the same terminal ray. So I would like you to draw these 3 pictures. Does it look like I drew the same picture 3 times? Right? This right here is our angle in standard position. The initial ray is on the x-axis on the positive side. The vertex is at the origin. And I'm just going to call this theta for today. And let's make theta 30 degrees. Okay. Is this angle right here 30 degrees? Could be, right? But we don't know. What if I say this angle right here, my initial side started here, and it opened up this way. Let's call this alpha. Anybody want to guess how many degrees alpha is? 330 is very close. It's actually really far from the actual answer, but super close. So we've been going like this when we've been doing our unit circle, 30, 60, 90, 120, right? What do you think happens when we go clockwise, when we go backwards? It's negative angles. Have y'all ever dealt with negative angles? No. You can have a negative angle now. So if I'm going backwards, what is my answer now? Negative 330. Because do you agree this right here was theta? So I would do theta minus 360. We said theta was 30. So what's 30 minus 360? Negative 330 degrees. Last but not least, I could have my initial ray right here, and I could go around and get an angle. Let's call this angle beta. Anybody want to guess what beta is? No? Which direction did I go? I went all the way around. 390. Why 390 degrees? Because do y'all agree this is still theta right here? But I did a full circle in that, so it's 360 plus theta, which is 30 plus 360, which is 390 degrees. These three angles are coterminal angles. They're different angles. Do you agree with that? Like, they're not the same number. However, on the unit circle, or on our unit circle, they look to appear to be the same angle. Okay? So if I asked you about 60 degrees, what is a coterminal angle to 60 degrees? You could subtract 360 and you would get negative 300. Or you could add 360 in 420. Could I add 360 again? Could this go around twice? Sure. 3 times? Sure. 50 times? Sure. We're not going to sit here and do that. But how many coterminal angles does 30 have? Infinite. Because I could go around the circle as many times as I wanted. Or I could go backwards around the circle as many times as I wanted. Okay? We're not going to do all that extra. But you just need to know that's how you find coterminal angles. Now, you just took a quiz. Camila will figure out when to have you take that quiz in a little bit. You just took a quiz. I should have waited till after to send you, but that's okay. Over the unit circle. And we learned 17 special angles on there. Do y'all agree with that? Are those the only 17 angles on this unit circle? No. How many angles are on this unit circle? Well, really a lot, because we have decimals and stuff, right? But don't y'all agree could I ask you 20 degrees, how many is that in radians? Do you have that memorized? No. I don't expect you to have that memorized. These are the only ones you have to have memorized. But can you convert 20 degrees to radians? Yes. So that's what we're going to do right now. So this next section is going to be called converting. And first we are going to convert degrees to radians. Alright, so let's do example 1 is going to be 200 degrees. Is that one of the special angles that we did? No. So how can I convert this to radians? We're going to multiply by what? We want pi, right? Don't all of my radians have pi? And what is equivalent to pi? Okay, although you are absolutely right. I apologize. Let me rephrase that question. In degrees, what's equivalent to pi? 180 degrees. And do you see how this is like a conversion thing? I can cancel out my little degree symbol, and I will be left with 200 pi over 180. Now, is that my answer? No. What can I do? I can simplify. I can reduce. Do y'all agree these zeros cancel out? Yeah. And does that reduce 20 and 18? What can I divide those by? So what will that give me? (10 pi over 9). Are we okay with that? What about if I wanted you to convert 75 degrees? What are you going to do? Multiply, same thing, by, are you always going to multiply by pi over 180? Yeah, that's not going to change. If you're converting from degrees to radians, yes. That's going to give me 75 pi over 180. Can I reduce that? How? What do they both divide by? Louder? 5. I can divide them by 5. I'm going to come down here. If I divide them both by 5, this is why you have a baby calculator. Maybe you can do it in your head, maybe not. What's 75 divided by 5? 15 pi. And what is 180 divided by 5? 36. Is that my answer? No, why not? Can I reduce it more? Yeah. What can I divide by now? So from here to here, we divided by 5. From here to here, we can divide by 3. And what does that give me? (36 divided by 3? Can I reduce it any more? No, I'm done. Could you have just reduced by 15 from the get-go? Sure. Would you have known that to do that? Some of you, yes. Some of you, no. So if you know the greatest common factor that you can reduce by, do that. But if you don't, you can just keep reducing. No big deal. Yes. Are you stretching? Oh, you're stretching. Do I have any questions? We comfortable? We okay? All right. Let's go the other way. What if I want to convert radians to degrees? We get out of here at 37. Okay. Radians to degrees. What do you think I'm going to do here? (180 over pi). I'm going to do the reciprocal of what we just did, right? Because this time I want to get rid of the pi's. What is 5 times 180? (900) divided by 3. Hey y'all, did I need to do that for this one? Why not? It's one of the ones you should have memorized. So we didn't need to do it. Can we do it? Obviously it works. But don't y'all agree we should have 5 pi over 3 memorized? Okay. I want to show you real quick your next quiz, which is on Friday, is going to be memorizing. Let me rephrase that. I'm not going to give you the circle this time. I'm just going to give you different questions, and you have to tell me, you have to convert it back and forth. I am not going to expect you to use this. I'm going to expect you to know it's the ones to memorize. So 225 is how many radians? (5 pi over 4). Okay, y'all have it when we write it down. Do we have it doing this? So this is in Schoology already for you. It's a Quizlet. What about 0 degrees? Oh, good, we got that one. What about 7 pi over 6? Okay, the process is, what quadrant is it in? And then where is it? Okay, it is 210. Good job. All right, next one, 3 pi over 4. Second quadrant, in the middle. 135. Okay, y'all catching on? 4 pi over 3. Some of you are like, no, this Quizlet will be, you have 2 days. It's not till Friday. Is it 240? It's 240. So that's going to be what your quiz looks like. Okay? And we're going to practice that tomorrow at the beginning of class and at the end of class. And we'll practice on Friday at the beginning of class. Did I tell you all about the 100 Club in this class? Yeah. Okay. 100 Club. Our goal is to make 100 on all 6 of these unit circles. And you get a place on my wall forever. We have some siblings on here, I've heard. A place on my wall forever. You get a huge bag of candy. Y'all who know Min Hugh. Y'all who know Min Hugh, ask him how big of a bag of candy he got. It also took me like a month to get it to him, but I got it to him. He said something with mochi. That's all I remember. All right, and example 2. So anyways, we'll go over that. Sorry, got sidetracked. Next one. This one's not on your unit circle. I'm going to give you, is that what it says? 13 pi over 18. Is that what I did first period? I guess it is. Somebody's going to have to tell me what 13 times 180 is, because I don't know. Oh, actually, you can do this one without a calculator. Yeah, what do you know about these two right here? They cancel and reduce to 10, right? And then what's 13 times 10? Again, you will have a baby calculator on this test, but that's how you do it. Any questions about converting? We're okay? Alright, I'm going to go on to the next page. I'm not going to finish it, but I am going to have you start the formulas. Alright, so if we can turn on over, that was page 3. So now we're going to be on page 4. We're going to start off with arc length. You actually learned both of these formulas in geometry. Don't know if you remember them. But arc length we're going to call S. What is arc length? Does anybody remember? Yes? No? It is a part of the circumference of a circle. Think of the crust on a pizza. If I was asking you, hey, what's the distance from here to here? I'm asking for your arc length. In geometry, you learned this formula. I don't know if you remember seeing it. M over 360 times, what's circumference? 2 pi r. In pre-cal, we are not going to use degrees. We are going to use radians. So, to find arc length, instead of m, we're going to call this theta. And instead of divided by 360, what should it divide by? 2 pi times 2 pi r. Well, what ends up happening? Am I going too fast? A little bit? No? Okay. My 2 pi's cancel. So what is my formula? Theta times r. This is the formula you are going to have to memorize. Theta times r. What is theta? The radian. Not degrees, the radian. What is r? Radius. Box that, please. You're going to have that memorized. Last thing. I got 3 minutes. I can do this in 3 minutes. I have longer than 3 minutes, but I can do it in 3 minutes. We're going to call A of S, and this is going to be area of a sector. An area of a sector is the area of a portion of a circle. It's like asking the area of your piece of pizza. A slice of pizza. It's not exactly a triangle, so can't use that. So we have to do the area of a sector formula. Again, in geometry, you did m over 360 times, what's the formula for area of a circle? Pi r squared. In pre-cal, we're going to use radians, so we're going to do theta over times pi r squared. What ends up happening here? The pi's cancel. And so instead of, you could do it all divided by 2, but instead of doing that, we use 1/2. We just make that divided by 2 at 1/2. Theta r squared. And this is the formula we will use in pre-cal. Tomorrow I'm going to go over how to use those formulas. What I'm handing you right now is the homework for the entire unit. It's 104 problems. However, they're not all due at the same time. On Monday, all of 1 through 16 is due. You have already learned how to do 1 through 8. You can get started if you want. Alright? This will be due Monday. I'm giving it to you early just if you want to get ahead. 1 through 16, it's on your calendar. 1 through 16 is due on Monday. You've already you kind of learned 1 through 12, but we haven't done any examples on 9 through 12. So don't lose this, please. It has the rest of your homework for the next 2 weeks. It is also online if you do, though. Do I have any questions? All right, y'all can pack up. Thank y'all so much for being awesome. And I'll have quiz A back to y'all tomorrow. Yes. Yes, the ones you've already memorized. Correct. So it'll be like that Quizlet you saw. Can you name pi over 4? What does pi over 4 equal? Huh? Yes. No, but you're not going to be using the formulas to do it. It's just you need to memorize them. It's these right here. So it's, can you tell me what does pi equal? It's like this, but instead of giving you a circle, I'm just giving you blanks. Yes. We're going to practice tomorrow multiple times. Don't worry about it.